Hi, my name is João Henrique Albuquerque. I'm an internship at NUI Galway, and this is a quick start system-on-chip applications using Z and Zybo boards demo. First of all, in order to use a Zynq device, which is the part of family where Z and Zybo boards belong, you need to understand a little bit of the architecture. The board itself, it's made of two parts: the processing system, the PS, which contains a dual ARM Core A9 processor, and also the programmable logic, which is something like the conventional FPGAs. In here, in the PS, we have interfaces that connected directly to the processor available on your board. We have some MIO pins, JTAG, MIO, GPIO, and also we have these signals and connections that sometimes make the bridges between whatever is happening in your processor and whatever is happening on your logic part. You have XII interfaces that's different from the buses because it allows a different kind of data transfer and also makes the communication between those two parts a little bit more difficult than the conventional FPGAs. In the application 1, I will demonstrate how to get the switches values to appear on the LEDs. The goal with this application is actually to get started with Xilinx Vivado and use the provided IP blocks to generate a design. Once that's done, we're going to generate a hardware configuration necessary to do what we want to do with this application. Once the hardware configuration is done, we're going to export the bitstream files and the hardware to the SDK to actually program the board. This is how the overall design architecture for this very first application should work. We will have a console on the SDK giving commands to our processor on the board. The processor will get this information passed through the XE peripheral, which will connect to the XE GPIO that commands the switches and the LEDs. The XE GPIO will also feed back the information from the XE peripheral and transfer them back to the PS. I would like to let you aware that the processor reset is low asserted. Whenever you're programming something and you have to do a reset, please be aware of this, or you might find something wrong with your application. For the difference between the two boards' communication is Zybo only has one USB UART, and in this case she does what the function that both USB necessaries for the Z board should do. She works as UART for the FPGA configuration and data I/O, while the Z board has one USB for each. In this very first application, we will get the values from the switches, light the LEDs, and if a certain amount of switches it's high asserted, we'll get the processor to light up a LED connected directly to the processor. So how those Xilinx tools will communicate between each other? We're going to make the Vivado hardware configuration to generate files for you. And then we're going to export those files to a folder local to your project on Vivado. And then we're going to launch the SDK to generate files and create a hardware platform specification for your board. And once that's done, we're going to generate a board support package to target the processor with the peripheral hardware available. And then we're going to start an application to put everything together, and we will allow you to debug or run the developed code in C# and interaction with the console. This is the overall. Right now I'm going to demonstrate how to get this done on the Zybo board first and then on the Z board.